Welcome from where we left off the last time when we were doing our TDD on our task manager. Let's go check our requirements. Open the README. On our README, we have completed that a task must have a name, owner, private collection, and users can view only their task. Then we have added this one to get a task by the index. Here on the edge, on the right, we have completed that a user can add one or more tasks. Then here we have added this requirement that we must not add an empty task onto the blockchain. So we have to go and write that requirements, because if you check here, you can you can add an empty task. So we must not allow our application to write an empty task. Let's say this is our first task. Let's go write that test. I have created a snippet. If I do MIT, then need to do my snippet. This task should throw exception if text is empty. Then we have to our text message equals to empty string. So what do we have to expect? Here we have to expect that if we try to add a task manager with the text message of empty, it's supposed to be reverted with the message that text is required. Then let's run our test. Supposed to fail because we don't have that requirements. So now the task is failing. Should throw exception if the task is empty, because now the task we don't have. We have to go to our smart contract. On our smart contract, we have to add the modifiers. You can do it in two ways, but I prefer to do it on the modifiers. So let's create modifiers. A modifier is a special function on solidity to check, to validate data that the user is sending. So in order to write the modifier, let's write first modifier is to validate text. So we have to prefix with the keyword modifier, then write the name. Our name will be validate text. Is supposed to validate our text, then therefore we have to pass the string memory underscore text. Then we have to validate this text. On the modifier, we have to require it's a special function to check the condition. Then what's our condition? Then what's our message? Firstly, let's write our message. The message is supposed to be equal the message that we're throwing here. That text is required. We copy this message, we paste this message here. Then we have to check our condition. Then our condition is is supposed to check the length of our text, and the text is a string. In Solidity, to check the length of the string, you have to convert. You can say it's casting, but converting the text to bytes. Then if we convert that text to bytes, then we have to check the length. The length of our text must not be equal to 0. If the text is empty is equal to 0, then it will throw this message. If it's not equal to 0, what do? Then you have to do underscore, then close, which means on Solidity, this underscore close, it means it will run the method that whatever code. If this one passed, then it will run the code here, this underscore code. Then we go to our message. In order to use this modifier, we go to add task. Here on the external, we have to pass our modifier. Then our modifier, we have to pass the parameter of text. Then now if we try to add empty text is supposed to throw a message, then let's save and run our tests to check. Now all the texts are passing. Now we can, if you try to put an empty, it will throw an exception. Then we have completed this one for throwing exception. We have to close it. Then the next one, we're supposed to get our task by index. Let's go and complete this one. Let's go to our task manager. Let's close this one. Let me copy this one. I'll need it later. Then here we are going to get task manager by ID or index. Then our snippet meet, then show get task by ID then the message is supposed to get task. You can call it get task by index or just get task. Let me be specific, get task by index. Then const index equals to 0, because we have added our task, so it will be 0. Then we pass our index to here. Then what do we expect when we get by index? Then we have a transaction. We have to wait until the transaction is completed. Then we get a receipt. Then after waiting this transaction, this no, now we don't have to wait this one, because now we are not sending, we are getting. When we are getting, it means like it is a task. If the task is already on the database, we're supposed to get that task. Oh, sorry. Then the task, we have to expect that the task message the text, that text, that, remember here we added a text, this text message. Let's copy it. We were supposed to add it on the global variable so that we don't have to copy each and every time, but let's do it this way. We have the message, then the message is this task message on the database is supposed to be equal to this message. Then another expect, we expect that our task completed status is supposed to be false. Then let's run our test and check. It's supposed to fail as we are following TDD. It's supposed to fail. If you can check now, it's failing because we don't have this method. We have to go to our task manager to check if then we create that method. Then it will be an external one. Then our parameters is supposed to be the uint, supposed to be the uint, (256), then memory, then we can call it task index. Then on this task index, because we are getting the task index, we're supposed to go to the collection of the user. Here on the collection, because this collection is an array of tasks, we have to go and take the index task of that index. Here on this method is supposed to return. It's supposed to return what? It's supposed to return the task. Or it's supposed to be a view. This one is supposed, we have index, then this one's supposed to return this index. So let's run our test to see if it's passing. all our test is passing. But what if we try to, let's go check here, it's passing. But what if we try to get on another, what if we try to get a task of index maybe 1, where we don't have that index? Here it's supposed to throw exception. It should throw exception that task is not found. If this task is not found, it's supposed to throw an exception. But here, let's run our method and see if it will throw an exception. Let's run our test to see if the task will pass or not. Now, you see it's reverted. If you check our errors, that the task is reverted because we can't find the task of index 1. Then on this task, we have to go here and create another modifier. Then on this modifier, we'll check if the task is not found. Let's copy this modifier and paste it here. Then we have to rename our modifier to be task not found. On this task not found, what do we check? We have to check the int 256 underscore task index. We have to check the index. What are the index? The index condition will be task index must be less than collection, because we are checking of user collection. Supposed to be less than user collection dot length, because if user 1 wants to query task of index 2 when the length of collection is 1, is supposed to throw exception. And because here is supposed not be equal to, because this index is on the array are 0 based, but the collection is start from 1. If there is one task, it will be the length of 1. That's why now it's less than. It's not less than or equals to, because here it won't be equals to 1. Then it's supposed to throw a message if the task is not found. It's supposed to throw a task not found exception. Then here on our on our message is supposed to, we have to expect it here because it's supposed to revert something. We go here and delete and paste it here and add this task. Then put the index. Then the message here, the message is supposed to be equals to this message that will be reverted by the smart contract if task is not found. Then we'll put this message here. Then save. Then let's check if our test is passing or not. Okay, no, we forgot to put this not found modifier on our get by ID here. We're supposed to put our modifier then we have to put your modifier on the get task by ID to check if the task exists. Then if we try to run again the test, see, now all the tests are passing. Then we have to go and get by index, then add task, must not allow, yes. Then we have to go and delete a task. Then we have to go to our test. We're supposed to write our test to delete our task. Should remove task by index. Then we have to copy these two, then put it here. Then what do we want to check? Yes, task by index, we have to delete our method supposed to be delete task by index. Then which task are we going to delete? Task of index 0. Then we're going to check here, because we are writing on the blockchain. It means like we wait for a transaction from the blockchain. Then on that transaction, we wait for a receipt. Which equals to await tx.await. When waiting this transaction, then we have to check if the task is deleted we can expect results in two ways. Firstly, we can write the event. When that event is raised, we can catch that event, then check if the event is successful. And another one, we can get a task count to count all the tasks. Then if the count is 0, it means like we have deleted that task. Let's do this one to delete, to get a count, so that the count must be 0, so that it will show that our task is deleted. Then let's try to run our test first. TDD is supposed to fail because we don't have the message. Then we have to create this delete task by index message. We go to our smart contract. We create a function to delete task by index. We know we have to call this method outside the smart contract, supposed to be external. Then what do we need? We need a task, the task index that we're going to delete. Then we put that task. And another thing we have to put, that's why I like modifiers, because now we have to check even if task is not found, because we can't delete task that's not found. Then we have just to put our task not found modifier, then it will run. Then we don't have to write that logic again and again. Then after that, we have to write a code that will delete a task from the database or the task from the blockchain. Then on the delete task, we're supposed to get the collection, because here we're using the collection, this collection. Then we get all the tasks of that user. Then we get the task by the index that the user passed. If the user passed this index, then it will be equals to collection dot sender, which is this message. Then on this one, we need to delete one. The one that we are going to delete, which is this task index, we have to put it the last. Here when we say task sender ID, we are putting it on the last, to be the last item of the array. Last item of the array. Here we have to put it on the last item of the array, this task. You will see why we need to put it on the last of array. To put it on the last of array, we have to do collection dot message sender dot sender dot length -1. Because the lengths array are 0 based, then we have to -1, so that this index will be the last one, this task will be the last one on the array. Then after that, after putting this index, because we don't know, you can find that this one is index 0, index 1, index 2, index 3. Then if it's index 0, we have to put the index 0 to the last of the array. Here we are putting this is the array. Then we are taking this one and put it on the last of the array. Why? Because on the collection we have to do this collection. On this collection we're supposed to pop, because it's an array. We can use the built-in method to pop. Then pop will delete the last item of the array. After deleting the last item of the array, what do? We can test, but now I want to write the event. Our event will be exactly the same as the task added event. Then we have to be task deleted event. Then we have to emit this event here. After deleting the task, we have to emit task deleted. Then on the task deleted, we need message.sender, the one who sent the message, and we need the time that it was deleted. We know in order to get a time, we need a block. Then on the block, we need the time stamp. Then we're done. Then we can run our test to see if everything is running well. Now, yes, the task it's removed. That's why now you can check here. You find like here the task is 0. That other way that I was checking if the task was deleted, because remember we added this task deleted event. We can also check the event, because on the receipt, this receipt will have the type of event that will be sent after deleting then we have to check post task deleted equals to, then we check the receipt dot events. This receipt will have events, all the events. If the events are raised or emitted, which is an array, we have to put this question mark to say if there is no events, I'm not supposed to throw error. Then filter. What do we have to filter? We have to filter the events. Then our event name that we are going to filter is supposed to be if.event. This is the name of the event, will be equals to, it's supposed to call the name of the event, which is task deleted. The name of the event was supposed to be equal to this one. Then what do we have to check? We have to check to expect a task deleted to be an array, because we know that we have emitted the task to be array. Then if it's an array, then this we have to expect again that this task deleted is supposed to be size of 1. Size 1, because we have one task. Let's try to check if the event is raised. When we delete, check if yes, the task is passing. Then we go to our, we can delete task, yes. Then we can update only task. Then we go to update task. Here we have to do the update, not on top of this one, because if we do the update below the delete, we can't update the task if the task is not available. Then we have to write our test should update a task. Then when we update a task, what do we want? We want a message to update a text. We are going to update like to change the status from or completed from false to true, or we can update both the status and the text. But for now, let's here update task, which is change status. On the change status, we're supposed to copy this one. Because we are going to write to a database, it's supposed to be a transaction. Then it's supposed to be update status. Here on the status, we need task index. Then we're supposed to be index of 0. Then we need a status const status equals true, or we can call it completed equals to true. Then we pass the status. Then we have to wait the transaction. Then cancel reset because I wait. Then what do we have to expect? We have to expect the status to be completed. How can we expect? We have two ways. We can raise the event, or we can get task by ID. Then when we get the text by ID, we check if the status is it's completed. Then we can do this. First way, we can get text by ID. Then we have to expect that the status completed equals to true. Then let's run our test. It's supposed to fail because we don't have that update status. Then the text it's failing. Then we go to our solidity smart contract. Firstly, we copy the message update status. We go to here, we create function that's called update status. Firstly, we need index. We copy the index, and again we need a bool status. underscore status. Then this message is external, as we have to call it outside, and we have to update only the tasks that exist. We have to check if the task exists. If not, it's supposed to revert with the error not found. We won't check because we have already checked when we are trying to add the task. Then here we go, because we're working on the collection, we need a collection. The collection of task index. If our task is 0, that we need 0. Then on the task 0, we need the status of completed to be equal to the status that the user is passing. This will update the database so that I have to use this one because it's simple. Because if we need to check to query the collection first, you need to make it a storage so that you have to change it. That's why here you don't need a storage, because you are mutating the collection directly. So then we need to update the user that the task have been updated. Then we need an event. We copy the event. It's supposed to be exactly the same as task deleted, but here task updated. So we have to go and emit this event. So we can copy this one because it's exactly the same as this one. Then we go copy the task name. The event name is task updated, not task deleted. Then we save this one. Then we go here and check if it's running. All our tests is passing. Another thing, then if we go check, we're done with our all the requirements. The only thing that you can do on your time is to check if the task is empty, to check maybe here, because we are updating the task, you can also update the task text. Here you can change the text. Then we're done with our smart contract. Then all the tests are passing. Then now we have to deploy our smart contract to a blockchain. That's a moment of proof now. We go to script, the script folder. On the script folder, we have this boilerplate code. Let me copy, because we are going to deploy, let's say, we call it deploy. Then we copy all the code from the deploy. So that it will be simple. Delete all the comments. Then we have a code. Then when we go to deploy our smart contract, what do we need? In order to deploy our smart contract, we need the name. Then the name, sorry for the sound outside here, of our smart contract, which is our task manager. I think we have to change even the name, even this name. But because now when we deploy our smart contract, we don't need a parameter, we have to remove this one. Then we deploy our, we can call it task manager also, a small letter T, because it's a deployed task manager. Then we get the address. This address will be the one that we need in order to do on our front end. We won't do the front end today, but I will show you how to do to make it the simplest way to deploy the smart contract. If we go back to our packet JSON, you'll see that we have our deploy script, which will deploy our smart contract. If we run, let's run our test for the last time to see that all the tests is for sure. You have to make sure that all the tests are passing before you deploy, because once you deploy it on the blockchain, you won't edit it's once and for all. So that's why testing is more important on blockchain development. You have to test that your application is supposed to do what was stated on its requirement, because you won't change. There is no version 1, version 2, because every time when you deploy it to the smart contract, you get new address. So let's try to deploy. Let's run and deploy. We are deploying to the network of Mumbai, which is a testnet for Polygon. Then you see here we have our address. That's the address that we can run our we can query our smart contract. But I want to show you the simplest way in order to run it on the client. For me, I preferred to create another script called copy.js. On this copy script, I will write a node script const fs. It also require fs. Then we also need a path. Path equals to require path. Then we also need artifacts. Remember, this artifacts folder will be generated when you run the test and when you deploy. Then on the artifacts, we'll have to const artifacts equals to require artifacts. Then you go to contracts. Then you need the task manager JSON solve. Then you need the JSON. The greeter. You need the task manager solve. Then you need this JSON. Let's go and check what is inside this one. You go this one, you go contracts, you go task manager, you go to this JSON. On this JSON, the only thing that we need here is the ABI. You can need this name if you want, but for now we need only this ABI. In order to get this ABI, that's why we create a function called copy. Then we need the address that will be generated when we deploy the smart contract. Then after copying, what we'll need, let's do our object called data. On the data we need address. We'll also need ABI, which on the ABI is called artifacts. We'll find it on the artifacts dot ABI. Then after that we have to fs dot write sync. We have to write a file. Where do we write this file? Here we can use drill name, then it will be plus, then we move our backward folder, then we go to client, then we go to lib, then we go to contracts, then we have to save the task manager. .json. Then this one, when we then we have to export before everything. Let's export module that exports equals copy. Then we need this copy on the deploy script here. We could say const copy equals to require a copy script. Then after we deploy our task manager, after we get this address, we need to put this address on this copy method. Then if we run the deploy again, we're supposed to deploy, we'll get a new address. You'll see the address that we'll get will be different from this one. Okay, now we're getting error here because we're not passing data. Sorry, here we're not passing data here. When we create we're supposed to JSON coding while talking string file. Then we have to write our JSON, which is the data that we're passing. Then it's supposed to be now, then true, just to format it nicely. Then if we write now it's done. You say now we done. Thank you for your time. Cheers.